A silent beam of light now moves faster than sound, faster than missiles, and faster than warning sirens. It costs only a few dollars per shot. It leaves no smoke trail, no explosion, yet it can disable threats in seconds. This is not science fiction. This is Israel's new iron beam laser system, and it is already rewriting the rules of modern warfare. For decades, air defense meant interceptors, rockets, and expensive missiles launched at incoming threats. Every interception carried a heavy financial and logistical cost. Today, directed energy weapons are changing that equation. The iron beam uses high-powered lasers to neutralize drones, rockets, and short-range threats with pinpoint accuracy. It represents one of the most important shifts in defensive warfare since the invention of radar. The idea of using lasers as weapons first emerged during the Cold War. For many years, power limitations, weather interference, and targeting challenges kept such systems from becoming practical. But advances in optics, energy storage, targeting software, and AI-assisted tracking have finally made battlefield laser systems viable. Israel's Iron Beam is one of the first operational examples of this transition. Iron Beam is designed as part of Israel's layered air defense network. This network already includes Iron Dome for short-range rockets, David's Sling for range threats, and Arrow systems for long-range ballistic missiles. Iron Beam adds a brand new layer. Instead of relying on physical interceptors, it uses directed energy to disable threats almost instantly. One of the system's greatest strengths is cost efficiency. Traditional interceptors can cost tens of thousands or even millions of dollars per shot. A single iron beam interception may cost only a few dollars in electricity. This shift changes the economics of defense. It ensures that defensive forces are not drained financially during prolonged conflicts involving large numbers of low-cost drones or rockets. Another critical advantage is speed. Light travels at nearly 300 kilometers per second. When Iron Beam locks onto a target, engagement occurs almost instantly. There is no flight time for an interceptor. This nearly eliminates delays between detection and engagement, which is vital when dealing with swarms of fast-moving drones. Iron Beam also reduces the risk of debris falling on civilian areas. Traditional missile intercepts can scatter fragments over wide zones. Laser interception typically disables the target in midair without explosive force. From a humanitarian perspective, this lowers unintended damage risks in populated regions. The strategic importance of Iron Beam becomes clearer when viewed through the lens of drone warfare. In recent years, drones have transformed battlefields worldwide. They are cheap, easy to deploy, difficult to detect, and effective for surveillance or attacks. Even non-state actors now operate sophisticated drone fleets. This has created serious challenges for conventional defense systems. Iron Beam directly addresses this challenge. Drones often fly low, move unpredictably, and appear in large numbers. Using missiles against such targets is inefficient and costly. A laser system, however, can engage multiple drones rapidly without reloading. As long as power is available, the system remains operational. Iron Beam's tracking system integrates high-resolution radar, electro-optical sensors, and advanced targeting algorithms. This allows accurate identification of small airborne objects even in cluttered airspace. Once locked, the laser beam maintains contact with the target until its structure weakens and the drone becomes inoperable. Weather is one of the few natural limitations of laser systems. Dust, rain, fog, and clouds can scatter laser energy and reduce effectiveness. Israeli engineers addressed this by designing Iron Beam as part of a hybrid system. When weather limits laser efficiency, traditional interceptors can take over. This flexibility ensures operational continuity under changing conditions. The system's power output is classified, but analysts estimate that Iron Beam operates in the tens or even hundreds of kilowatts. This level of energy allows the beam to heat target materials rapidly, weakening structural components within seconds. What once required explosive force can now be achieved through precision energy delivery. From a military strategy standpoint, Iron Beam shifts the balance between offense and defense. For many years, The advantage often leaned toward attackers using cheap rockets or drones to overwhelm defenses. Laser systems restore defensive advantage by making saturation attacks far less effective and financially sustainable. Beyond Israel, Iron Beam has global implications. Many countries face similar threats from drones and short-range projectiles. Defense planners around the world are closely watching Iron Beam's development and testing phases. Directed energy weapons are likely to become standard in future air defense architectures. The humanitarian impact of such systems deserves careful attention. While weapons development always raises ethical debates, Iron Beam's defensive role and reduced collateral risk offer certain protections. It is designed to protect cities, infrastructure, and civilian populations from aerial threats rather than to project force offensively. The emergence of Iron Beam also reflects a broader transformation in military technology. Warfare increasingly revolves around sensors, data fusion, automation, and energy management rather than simply explosive power. Defense is becoming faster, smarter, and more precise. Israel's experience developing layered defense systems played a major role in Iron Beam's success. Years of real-world threat data allowed engineers to tailor the system to actual operational needs rather than theoretical models. This practical foundation gives Iron Beam a level of battlefield readiness that many experimental systems lack. Iron Beam does not replace Iron Dome. Instead, it complements it. Iron Dome remains essential for countering large rockets and missiles during mass barrages. Iron Beam handles low-cost aerial threats where missile interceptors would be inefficient. Together, they create a balanced defensive structure. Another major benefit of Iron Beam is logistics simplicity. Missiles require manufacturing, storage, transport, and reload cycles. Lasers require electricity. As long as generators, power grids, and cooling systems are functional, Iron Beam can continue operating with minimal resupply needs. Iron Beam also offers stealth advantages. Traditional intercepts are visible across long distances. Laser engagements have minimal visual signature. This reduces both public panic and enemy reconnaissance feedback, making it harder for attackers to analyze defensive behavior in real time. Directed energy systems also reduce the risk of interception failure caused by electronic countermeasures. While lasers can be affected by atmospheric interference, they are immune to many jamming techniques that target radar-guided missiles. This adds resilience to the defense network. The global arms race is now expanding into the domain of laser weapons. Major powers including the United States, China, and European nations are all investing heavily in directed energy research. Iron Beam gives Israel a leading position in this field. The long-term future of laser warfare is still unfolding. Future systems may operate at even higher power levels, allowing them to engage larger targets such as cruise missiles. Mobile versions may be mounted on vehicles, ships, and aircraft. Iron Beam stands as an early chapter in this new era. Critics argue that directed energy weapons could accelerate arms competition. That risk exists. However, defensive technologies often stabilize conflicts by reducing the effectiveness of surprise attacks. When offense becomes less practical, escalation risks may decrease rather than increase. Iron Beam also carries political significance. Its development demonstrates the importance of domestic defense industries, technological independence, and innovation under security pressure. Countries that control such advanced technologies gain strategic autonomy in defense planning. From a civilian viewpoint, systems like Iron Beam create a closer connection between everyday life and high technology. Power grids, cooling networks, radar stations, and AI software now form part of national defense. The battlefield increasingly overlaps with digital infrastructure. The psychological effect of Iron Beam should not be underestimated. Attackers who once relied on low-cost aerial weapons now face a defense system that can neutralize them instantly and cheaply. This changes behavior, planning, and willingness to engage. Iron Beam also introduces new training requirements. Operators must manage power systems, sensor fusion platforms, and engagement protocols rather than missile stocks. Defense roles are becoming more technical and data-driven than ever before. In regional security terms, Iron Beam strengthens deterrence while reducing escalation risks. By neutralizing lower-level threats with minimal physical destruction, it helps prevent localized incidents from escalating into broader conflicts. Global militaries are already planning around this shift. Drone warfare will not disappear. Instead, it will evolve alongside directed energy systems in a constant cycle of adaptation. Iron Beam's success also depends on international cooperation in certain components, from power electronics to optical materials. Modern weapons systems are rarely purely national creations. They reflect global supply chains, research collaboration, and industrial ecosystems. As the world moves deeper into the age of automation and AI, laser systems like Iron Beam will likely integrate autonomous targeting under strict human oversight. This raises important policy questions about rules of engagement, accountability, and transparency. From a humanitarian lens, the promise of reduced debris, faster interception, and lower unintended damage offers cautious optimism. Defensive systems that prioritize protection without widespread destruction represent a positive direction for conflict mitigation. Iron Beam does not end warfare, but it changes how certain battles are fought. It pushes warfare further into the domain of algorithms, energy systems, and intelligent sensors. The future battlefield may be quieter than past battlefields. No explosions in the sky, no missile trails, just invisible beams of light operating at the speed of physics. Israel's Iron Beam shows how fast that future is already arriving.